Okay, well, let's get started. I'd like to thank you first off for taking the time to attend our presentation this afternoon. Hello, my name is Lance Zurich, and today we are going to take a brief look at the two special curriculum-based sets from Studica that are designed for introducing students in middle schools, high schools, and homeschools to the fundamental principles behind mechatronics. Now, each of these sets are designed for conducting a project-based class, and that's where students will be required to design and build a series of original prototypes based upon their own research and activities. And each set includes standards-focused curriculum, which was created especially for Studica by noted educator and STEM expert, Tom White. So today we're going to start off where so many technology-focused presentations for education seem to start these days, and that is with the skills gap that exists. Now, when you hear someone reference the skills gap or the need for better STEM education in the schools, STEM, of course, being an acronym which stands for science, technology, engineering, and mathematics, well, what they're essentially talking about is the urgent need to prepare our students with the background they need to successfully compete in the job market which they're going to graduate into. Now, in the employment market that once greeted our grandparents or even our parents, a good work ethic, a strong back, and basically being able to take direction might have been enough to land a good paying job where many of the technical aspects could be learned on the fly. But now students must be prepared to enter a world that is increasingly focused on programming, automation, IoT, and rapid advances in all aspects of technology. So in short, students must be able to demonstrate technical literacy and aptitude if they hope to compete and to succeed. And this is, of course, why so much of the emphasis in education over the last decade has been on developing STEM skills. Every new advantage which we enjoy, such as the tablets and the smartphones, which we all use daily, were created because of individuals who helped to make those advances. Now, countries all around the globe, countries like China and India and so many others, are making major strides in developing new technological advances and preparing their own students to take their place in the future workforce. Here in the United States, we also need to prepare the next generation of graduates with the skills, the mindset, and the habits that will enable them not only to secure jobs, but also to be part of the next wave of advancements which we rely on to stay competitive on the world stage and to maintain our stature as a world power. Now, as I have no doubt that anyone attending a webinar like this is already in agreement about the importance of STEM and technology-focused programs, we're going to now move right along to the main topic, which is, of course, mechatronics. Mechatronics has been called the science of intelligent machines. It's a study that focuses on electrical systems, control and mechanical systems, robotics, the Internet of Things, and computer science. All extremely important subjects for students to be exposed to and all skill sets that are highly prized in today's technology-focused job market. But just how prized? Well, per the website careerexplorer.com, the average salary for a mechatronics engineer in the United States is currently around $96,980 per year. So while, of course, the students who go on to secure these prized career positions are the ones who prepare themselves by pursuing the proper post-secondary coursework, they do need to start developing the habits and the career focus as early on as possible in their education, in high school, if not even in middle school. The dilemma for educators because of this, whether in the classroom or the homeschool, is in finding ways of introducing this type of subject matter to students in a way that gets them interested and involved in the learning process and not just memorizing obscure facts or ideas just so they can take a few tests and then promptly forget them. No. To best help students to be successful and to really encourage them to consider pursuing further education in subject matter like this, educators need to be able to present the material in a way that makes it relevant, which means answering the eternal student question, why do we need to know this? And it also needs to be engaging in a way that holds students' attention much better than rote textbooks and lecture presentations, and something which has real visible, real world applications in which the students can get involved in doing things hands-on. Now, it is with this dilemma in mind that we created the Studica Mechatronics programs. These two special sets, you see the instructions for each on the screen right now. One is designed as an introduction to the world of mechatronics, and one of which is intended to be essentially a standalone class dedicated to the subject of mechatronics. These were each created to provide all the materials in one place that educators will need to enable them to offer a project-based class that is relevant, engaging, realistic, hands-on, and which is crafted to meet the most current academic standards. Each of the two Studica Mechatronics program sets comes with its own detailed day-by-day curriculum document, which was created again specially for Studica by noted educator and STEM expert Tom White. The curriculum itself comes as a downloadable PDF, which is available for free with the purchase of each set in any quantity. This curriculum is designed to align to the most widely accepted academic standards which are currently in place in the United States. The curriculum is also designed for offering a project-based learning program, and this means that solving the problems that arise in each unit will require the students to be actively involved in the research, the design, the trial and error experimentation and activities, as well as the building of actual working prototypes that will help to provide the required answers to the questions. And students aren't asked to do this alone, no. Instead, they're going to be asked to work in small groups or teams of 4 students each. And the reason for this is this will help to develop the soft skills that students also need, maybe just as much as they need to develop technical skills. And of course, when we're talking about soft skills, we mean things like communication skills, teamwork, adaptability, problem solving, and leadership. And finally, with the exception of some very affordable programming software, each set includes all of the physical building materials that each group will need to enable it to address all the design projects presented throughout the course of the curriculum. The curriculum is designed to enable teachers of all backgrounds, and by this we mean even teachers from non-science or technology-focused disciplines, to have the information they need at hand to properly prepare them for conducting the activities and to increase their comfort presenting this material to their students. The curriculum is designed to be clear and easy to follow, providing a clear roadmap for student learning. Various supplemental materials are included both in link form throughout the curriculum and also at the end of each unit. And there are also special tutorials on familiarizing students with the building system they will use to address the projects which are presented in each of these units. The units in the curriculum are designed as a series of projects. Each of these projects is presented to students in the form of an engaging, real-world style scenario, where students must work together in small teams, and again by this we mean 4 students per group, to help to create a solution to the problem. The project units each contain embedded academics. And at the end of each unit, the students will be required to make a formal presentation of the prototype that they have created to address that particular unit's real-world scenario, and to explain the reasoning behind the way they constructed their prototypes. There's also a technical literacy task driven by each of these projects. As students work to address each of these projects, they will acquire the knowledge they need through inquiry and exploratory research. Science, math, and technical skills are acquired through the carefully designed enabling activities. And again, as required by each project, students will be asked to create original prototypes and any required programming-based solutions, and also to maintain detailed documentation during the entire process. Now, as I mentioned a few times in this presentation, the curriculum that accompanies each of the Mechatronics program sets was created especially for Studica by a man named Tom White. Now, Tom is a noted educator who's been involved in teaching STEM and technology since the 1970s, designing programs for educational institutions and for industry. In fact, as an expert in hardware and software integration, Tom was pivotal in introducing CAD, CAM, control systems, digital control, additive manufacturing, and other like topics to the classroom. Now, currently, Tom is the Director of Technology for STEM curriculum at the globally recognized industrial manufacturing company, Siemens. The standards addressed in the Studica Mechatronics programs are the most widely accepted standards currently in place in the United States. And these include the college and career readiness standards for mathematics, reading, and writing, as well as the next generation science standards for K-12 and standards for technological literacy. And as I mentioned earlier, the programs are designed to be project-based. So when students ask, why do we need to know this? It's usually because the subject matter that they're being presented with might come across as either too abstract or just not useful in their lives. But with this project-based approach, students get to see firsthand why these things are necessary to learn and where they're useful. The concept of working in the small groups to solve each of these project problems also helps students to develop the high demand soft skills, as I touched upon before, that employers look for. Again, skills like communication, analytical skills, quantitative skills, flexibility, adaptability, and problem solving. In this project-based format, all of the subject matter is integrated. The math is integrated with the reading, the writing, and so on, which is of course ideal for STEM education. And because of the manner in which students must approach each of the projects being put forth in the curriculum, again with the research, the testing, and the group give and take, just to give a few examples, this helps to allow for a much deeper exploration of problems than traditional teaching methods might allow. The projects presented in each unit are also designed so that if you have several groups working on the same project, you should see variations in their prototypes and of course in their solutions. Now this can be because of creativity or differences in research and the different approaches taken by each group. But in any case, students get to see firsthand that problems can have many different answers and that often there is not only one right answer. Each project in the curriculum presents students with the opportunity to plan, organize, and conduct research. The enabling activities that students are asked to engage in provide them with the skills and knowledge they need to draw on to complete each project just in time. And students will be required to do extensive research as they complete these projects. Research that is utilized in the design, the prototyping, the testing, the evaluation, and redesign phases of each of these solutions. And once again, the Studica Mechatronics sets are designed specifically to work in for students to work in small groups. Each set contains enough materials for teams of 4 students. The team approach, again, as stated before, helps promote soft skills such as communication, the ability to work well with others, and leadership. And in addition to this, the sets also offer an easily scalable approach. Just divide the number of students in your classroom by 4 to determine the number of sets needed for each class. And again, everything you need to conduct the program, with the exception of the programming software that I mentioned before, is included inside of each box. Access to the free curriculum download is included with the purchase of each set. And also included are all of the building materials which students will use in the creation of each of their prototypes. The materials are from the unique Fisher-Technic building system, and among the components included in each set are 2 robotic controllers, like the one you see on the screen now, and 2 power supplies. Of course, many of you may not be familiar with Fisher-Technic, so please allow me to provide you with just a little bit of background. Fisher-Technic is a flexible and innovative construction system. Now, unlike other popular construction sets where they're designed simply to stack, Fisher-Technic was created with more of an engineering mindset. The core building block in the Fisher-Technic system is unique in that it allows attachment from all 6 sides, and because of this, it allows for almost limitless design possibilities. Many of the parts in the system are designed to slide together and lock in place using a tongue and groove assembly method. The system also includes a wide selection of very specific parts, variations on gears, girders, sensors, and so much more, which will allow technical builders to address equally specific design needs. Fisher-Technic was created in the 1960s by German inventor Arthur Fisher, who's noted for countless innovations used in the construction and the automotive industries. Mr. Fisher, at the time of his death in 2016, held more patents in his name than Thomas Alva Edison had amassed during his own lifetime. Now, besides Fisher-Technic, Mr. Fisher was the inventor of synchronized flash photography back in 1949, as well as being the creator of the expanding nylon wall plug, which is used in conjunction with a screw or a bolt to help anchor heavy objects to walls. His company, the Fisher Group, employs thousands of individuals worldwide, producing many variations of fastening devices used in building construction, as well as components used in automobile manufacturing, and they're also known for providing consulting services related to automated processes. With all of that being said, let's begin looking at each of the 2 individual sets. We're going to start off with the Studica Introduction to Mechatronics Program set, or for those of you who like acronyms, you can refer to it as SIMP. The set is designed to help provide a well-rounded introduction to the core concepts of mechatronics. Each set includes access to a free download of a 242-page curriculum document entitled Mechatronics Fundamentals, written by Tom White. The curriculum contains enough activity material to fill approximately 45 academic hours. And as such, we recommend this program set for insertion into regular related class activities, for use as a short class unto itself, for after-school program use, or of course for homeschool use. The curriculum created for the set is again standards focused, using the academic standards most widely recognized in US-based education today, and it's designed for offering a project-based learning program. The set is designed for use in middle or high school classes, or again, for addressing the grade levels in a homeschool environment. The set contains a collection of over 700 Fisher Technic building components, and this will include everything from gears, wheels, axles, blocks, sensors, and much, much more, as well as, again, 2 robotic controllers and 2 power supplies. Only the required robotic control software, which we will discuss later, is not included, but again, it is very affordable and available separately. The curriculum for the Studica Introduction to Mechatronics program set consists of 6 project units, and they are as follows: sketching and documentation, simple machines, mechanical systems, basic electricity, conversion and storage of energy, and an introduction to control systems. There are also activities included to address the following topic areas that come up during the course of the curriculum, including sketching, linkage diagrams, schematics, Ohm's law and power, pneumatics, flow charts, using software and robotic controllers, working with sensors such as the digital switch and the digital phototransistor, working with open loop and closed loop programming, digital branching, analog sensors such as the photocell LDR, analog branching, again, analog sensors such as the MTC resistor and the potentiometer. Now, before we go further into the structure of the curriculum, let's first take a minute and look at what is covered in the second set. And this is the Studica Teaching Applications of Mechatronics Program, which could be referred to, if you like acronyms, as STAMP. Now, this set is designed for those educators and homeschoolers who wish to provide a more in-depth exploration of the fundamental aspects of mechatronics. The set comes with access to a free downloadable 400+ page curriculum document entitled Mechatronics Applications by Tom White. The activity materials in this curriculum document, when used in conjunction with the contents of this set, is designed to fill approximately 180 academic hours. So essentially 4 times the amount of academic hours is covered by the previous set. Now, as such, this can be seen as a more expansive version of the material touched upon in the previous set, and it's designed for those educators who are able to dedicate a daily class period of approximately 50 minutes a day, 5 days a week, or the equivalent, each week for a full academic year. Again, this set is designed for offering students a standards-focused, project-based learning experience and is designed for use in middle school, high school, or for addressing similar grade levels in a homeschool environment. The materials in the set consist of a selection of over 1,200 Fisher Technic building components, and once again, this will include a wide array of gears, blocks, sensors, axles, and much, much more, as well as, again, 2 robotic control units and 2 power supplies. And again, software is required for this set and is sold separately. Now, there are twice as many project units included in the Studica Teaching Applications of Mechatronics program set as with the previously discussed set. And this includes units on the following: sketching and documentation, simple machines, mechanical systems, basic electricity, and that's followed by project units focusing specifically on the creation of a garage door, an elevator control, an automated pneumatic clamping system, an automatic pneumatic feeder system, a conveyor with a counter, a robotic control, a sun tracking solar panel, and a color sorting machine. And again, during the course of the curriculum, links are provided to tutorial sections and activity materials for students to utilize. And this includes sections on things such as sketching, linkage diagrams, schematics, Ohm's law and power, flow charts, using software and robotic controllers, open loop programming, sensors such as the digital switch and the digital photo transistor, closed loop programming, digital branching, logic gates, combinational logic, edge triggered versus level triggered, pneumatics, variables, positions, recording positions, creating a graphical user interface, analog sensors such as the photocell LDR, the NTC resistor, the potentiometer, and finally, working with data. Now that we've had a look at how each of these sets differs and the specific subject matter covered by each, let's now look at exactly how the curriculum itself is structured. Both versions of the curriculum share the same format when it comes to the structure of each project unit, and as already discussed, each version will include tutorial materials, activity materials, standards, and supplementary materials. Now, in each case, the curriculum is also designed to be turnkey. Each set is designed to clearly spell out everything being addressed and again, to provide tutorials and other information as the topics arise. Now, this was done specifically to enable teachers from all kinds of backgrounds, including those teachers who may come from a non-science or non-tech focused background, to quickly become comfortable with delivering the material by reviewing each section before they present it in class. Each unit presented in the curriculum for each of these sets includes the following select sections: the introduction, the purpose of the project that's going to be explored, the concepts that are going to be addressed, an outline, the standards that will be met, an assessment rubrics, the essential question, the student scenario, the real world scenario I touched on before, the daily plan, vocabulary, and resources. Now we're going to take a look at each of these sections a little bit closer. Again, the unit starts with an introductory section and the purpose of the project. Now, just as you would likely gather from that name, this is the section that provides a brief description of the topic that will be explored in the coming days and activities. And this is also the section that seeks to clearly spell out to the students why they are learning this material and why it is important for them to know. The next section focuses on the main concepts to be addressed in this unit, and these can be thought of as the broad ideas that will be explored in the following days and in the core information that students should take from this project that will be essential for them to understand and utilize, not only today, but to hopefully draw upon as they move forward in STEM fields of study, and if they choose to pursue it further, of course, in STEM-related careers. Following this, we encounter the outline. Now, in this section, we drill down more specifically to what we will be addressing in this unit. Now, as the example I'm showing on the screen right now is taken from the unit that addresses aspects of programming, you will see that we touch upon areas such as the methods for writing programs, for example, flowcharts, word problems, etc. Program characteristics such as being open or closed loop. We deal with different types of branching, digital, analog, subprograms, and so on. Now, in the next section of each project unit, it will focus on the specific academic standards which will be addressed in that particular unit. Now, as you will see, this includes college and career readiness math standards, reading standards for literacy in history and social studies, writing standards for literacy in history, social studies, science, and technical subjects, the National Research Council's Next Generation Science Standards for grades K to 12, and standards for technological literacy. Each project unit also contains rubrics, and this will include both rubrics for the specific project being covered, along with general rubrics for literacy tasks. Next up, we find the essential question, and this can be thought of as kind of as the big picture question that will be focused on in each of the smaller individual activities that students are going to go through, and of course, all the aspects of the larger project which students will be asked to complete in this section. The student scenario is where the specifics of the project to be addressed are finally spelled out. Now, this is presented again in the context of a real world style scenario where students are presented with a problem that needs to be solved with the creation of some sort of, let's say, a device, a machine, or a mechanism. But either way, the students have to create something that's going to help to address this problem. Now, as I mentioned before, students are not going to do this alone. They must work together in small teams to craft their answer to this challenge. And solving this problem is going to require each of these teams of students to design a unique and original answer, which once again will usually be in the form of a working prototype along with whatever programming might be required. Now, just to provide an example. Now, if you look closely at the student scenario that I've chosen for the example on the screen right now, you will see that the project in this unit has each group of students take on the role of a design team employed by a firm that manufactures garage door openers. Now, in this particular case, students are being required to design a specific type of control system for a new line of garage doors. The manufacturer's requirements are all spelled out, such as in this case, the use of limit switches, meeting certain safety codes that require a method for sensing if anything is in the way of a closing door, and also the incorporation of an automatic light. Now again, each team of students will be tasked with creating both a unique and an original prototype, and in this case, of course, that's the garage door opening system, as well as the programming needed to control the prototype in question. Now, as they move through the challenge put forth in this scenario, each student team will be required to document the entire process in both the design notebook and digital engineering journal. And again, noting all of the research, all of the trial and error experiments, keeping copies of all design sketches and revisions, and so on. And at the end of each of these project units, each team of students will be required to make a formal presentation in front of the class, during which they will be asked to demonstrate their prototype and programming in action, much as they would be required to do for an actual employer or client in the real world. The next section we encounter is the daily plan. And this is the section that spells out clearly, both for students and for teachers, what's going to be expected of students, how the teacher will conduct the day's classroom activities, and what specific subject matter will be covered. Now, for example, some days may involve discussions, other days might involve research, or perhaps building small projects that help provide the building blocks that students will draw on to complete their larger projects as described in the student scenario. But in short, you can kind of think of the daily plan as being a roadmap designed to keep everyone on the same path. Now, you'll see too that along the way, as different aspects are addressed in each day's activities, such as, for example, what is required in a design notebook, or how do you use the control software, how do you work with the controller, or flow charts, or what have you. But either way, as these things come up, there are links to sections that will provide further instructions and information in each of these areas. At the completion of each unit, after the last day of the daily plan, is a section containing vocabulary. And you can think of this as important words and terminology introduced during the project unit, as well as a selection of useful resource materials. And these resources can contain a mix of different types of material, everything from carefully vetted websites and video links, to even PDF documents, PowerPoints, much more. Now, besides the project units, each of the curriculum documents also includes a special tutorial section designed to educate both students and teachers on how to use the Fisher Technic building system. Now, this includes information on how the various parts fit together using the pin and groove assembly method, identifying the different types of parts from the various types of girders and blocks, and the different types of axles and gears and rivets and much more. And students will also get to build a very basic sample model just to help familiarize them with the system before they move on to their larger projects, which are contained in each unit. And as learning about and maintaining proper documentation is one of the areas stressed in the course of the curriculum, there is a section which details just what defines each type of documentation, which you see listed on the screen now, and what is required for each. So for example, if a student needs to know what's required of a design brief, they can go to a section that's going to spell that out. Or if they need to know more about a project management plan, again, there's a section that will detail that. Now, as the process of conducting these types of more open project-based class activities may also be new to many teachers, there is also a section that discusses specifically project-based STEM education and its benefits. And that completes our overview of these two sets. And with that in mind, let's quickly review the contents and purpose of each set, but this time with pricing. First, we have the Studica Introduction to Mechatronics Program set, which is again designed as a standards-focused, project-based introduction to the core concepts of mechatronics. Once again, this includes the highly detailed 242-page curriculum document entitled Mechatronics Fundamentals, written by noted expert and STEM educator Tom White. The curriculum, when used in conjunction with the building materials in this set, will provide teachers with enough activity material to fill approximately 45 academic hours. It is again designed for those educators who wish to offer a shorter class in this material, who wish to use it in after-school programs, or of course, those who wish to use it for homeschool use. The teaching material is designed for use in middle schools and high schools, or again by homeschooling parents seeking to address STEM and mechatronics for these grade levels. The physical materials included in this set include a selection of over 700 components, which will include blocks, gears, sensors, and much more, again taken from the Fisher Technic building system, along with 2 robotic control units and 2 power supplies. These materials will again be used to construct the mechanical prototypes addressed in each project unit of the curriculum. Software is again required. We'll touch on that in just a second. But again, each set is designed for use by a team of 4 students at a time, with pricing starting at just $699 for a single set. Discount classroom pricing for groups of 20 students and up is available by quote upon request. Next up is the Studica Teaching Applications of Mechatronics Program set. Again, this is designed as an in-depth, standards-focused, project-based exploration of fundamental aspects of mechatronics, which is based around a highly detailed 401-page curriculum document entitled Mechatronic Applications, written by noted STEM expert Tom White. When used in conjunction with the building components included in this set, the curriculum is designed to provide enough activity and material to fill approximately 180 academic hours. This is designed specifically for those teachers and those homeschoolers who are able to dedicate a daily class period of 50 minutes per day, 5 days a week, or the equivalent on this subject for a full academic year. The set is designed for use in middle schools and high schools again, as well as by homeschooling parents seeking to address STEM and mechatronics for these grade levels. Each box contains an assortment of over 1,200 components taken from the Fisher Technic building system, again including blocks, girders, gears, sensors, axles, and so much more, and again 2 robotic control units and 2 power supplies. The required software is sold separately. Each set is designed for use by teams of 4 students, with pricing for a single set starting at only $799 each. And again, discount classroom pricing for 20 students or more is available by quote upon request. And as I've mentioned that software is required, let me address that real quickly too. The software in question is Fisher Technic RoboPro software, which is graphic programming software. And this means that it uses a flowchart style design using various icons, which students arrange and link to create the programs used for each of these models. It's an ideal format for teaching the fundamentals of programming to users of all levels. Pricing for a single user license is only $36 each, and unlimited single site school licenses, meaning that you can have unlimited users at a single site or building with this license, and that means whether it's 1 computer, 100, 200, or more if needed, the cost is only $120 per site license. And please note that these are not subscription prices, they're not annual licenses. These are non-expiring licenses you can access and use as long as you have the software disk which comes with each of these, and as long as you're able to install them on a compatible Windows-based desktop or laptop computer using Windows either version 7, 8, or 10. And on that note, if you have any questions, this would be a great place to ask them. Again, you could use the chat window, you could use the question and answer window. I will go once, I will go twice. If you do have questions, you can still type them in, but I'm going to move to the next slide. And this is about taking the next step. So if you're ready to take the next step, meaning if you'd like to request a quote, if you'd like to speak to the dedicated educational representative for your state, or if you'd like to find out more about either of these sets or any of the other Fisher Technic educational solutions we offer or other educational solutions we offer, you can simply call us toll free at 888-561-7521, or if you prefer, you can also email us at info Studica.com. Now, if you have any specific questions about anything that I've discussed today, or maybe things that you wish that I would have touched on, or if you have any questions about Fisher Technic, since I've talked a little bit about Fisher Technic and you'd like to know more about the line of Fisher Technic education focused solutions for teaching about STEM and technology, you can also email me directly. And as you see, my email is up there. My email is lance.zurek, that's lance.zurek @studica.com. And if you email me, I'll be happy to answer any questions you might have. So on that note, I'd like to thank you very much for taking the time to attend today's presentation. And we very much look forward to speaking to you soon. So have a great afternoon and stay safe. Take care.